On this question, we will find the inverse of this function, and after that we'll find the domain and range of the function and the inverse. To find the inverse of a function, a one-to-one function, we do this following steps. The first step is to replace f of x by y. So that is y. The next step is more important. We'll interchange x and y. So just x becomes y and y becomes x. Then we will solve for y. And to do this, first we get rid of the denominator by multiply both sides by 4y minus 5. And 4y minus 5 cancel with the denominator. And multiply this out. We have 4xy minus 5x equal to 2y. Both of them have y here. So we need to bring on one side. So I will minus 2y on both sides. And at the same time move the 5x to the other side by adding them. So we will have 4xy minus 2y equal to 5x. Since both of them have y, we can factor them out. Factor the y. We have 4x minus 2. And finally, to solve for y, we divide 4x minus 2 on both sides. We have y equal to 5x. 4x minus 2. The last step is just cosmetic. We replace y by the notation of the inverse. And we have that. And that is the inverse of the function. Next step, we will find the domain and range of the function and the inverse. To do that, first we do need to check to make sure that we actually find the function, do it correctly. So first, let's zoom out a little bit. And then bring the calculator up. Right. First, we will graph the function and then the inverse. So if I graph 2x divided by 4x minus 5 and we see the graph. Right, so that we will graph the inverse later, but now since we see that, we should write the domain and range. As we see on the graph, the domain on the x values will be all real number except for where there is the vertical asymptote. We could see that the vertical asymptote is at where x equal to 5/4. So to find the vertical asymptote of this function, we let the denominator equal to 0, and we have 5/4. So we write that because the vertical asymptote is equal to 5/4. Right. We should write as the interval notation. Next, the range. We see that the graph of the function, again this is the function, we have all the y values except for the horizontal asymptote. The horizontal asymptote for this function, since degree on top and degree at the bottom are the same, we divide the coefficient. So that would be 2/4, which will be 1/2. And y not equal to that. It's not the reason, but just note that the horizontal asymptote is 1/2, because the graph may still intersect the horizontal asymptote, but not on this problem. On this problem, 1/2 is the horizontal asymptote and the graph does not intersect it. And we will write this in interval notation. Everything but 1/2. Right. So that we have the domain and the range of the function. Now we'll graph the inverse. The inverse is 5x divided by 4x minus 2 and we'll see the graph. Now kind of difficult to see, but the graph of the function will be symmetric on the line y equal to x. So let me add the line y equal to x. And let make that a dotted line. So we see that the two functions actually symmetric on the line y equal to x. So that is the properties of the inverse. And so the function we found is correct. And also we can see that the vertical asymptote of the function is the horizontal asymptote of the inverse. The horizontal asymptote of the function will be the vertical asymptote of the inverse. And then properties of the domain and range for the function and the inverse. Finally, we can write domain of the function equal to the range of the inverse. And we don't need the calculator anymore. That is because we interchange x and y, so the domain and the range also interchange. So domain of the function, the range of the inverse will be this. And the range of the function and the domain of the inverse will be equal to this. And that's how we find the inverse of the function, and then use these properties to find the domain and range of the function and the inverse.